imagine
what that would be like.
Yeah, what you're seeing.
I mean, I don't necessarily want to think about it. You know, it's a little dire, but it's interesting. And you also said it's like Jupiter's moon.
Yes, yeah, it's standing on Jupiter's moon, like Europa, which has a solid surface. Like that would be similar.
Which just goes to show you how powerful our sun is.
It is, and that NASA spacecraft can have solar panels that are solar operated out there. It's a very tricky thing, but. I just think it's incredible. We're so lucky, right, to be not just here in this place, but at this time and in this solar system. I mean, there could be billions of stars out there, planets where there are alignments like this happening, but is there anyone there to appreciate it?
Right.
I mean, Carl Sagan once said that we are a way for the universe to know itself. And I think that is absolutely true for something like today.
100%. Yeah, I mean, truly, and we're not here to enjoy and learn something from it.
Well, and we actually don't even have that long, because at least for a total eclipse, we only have about 5 million years, because the moon is slowly moving away.
Yeah.
And eventually it's going to be so far away that we're only going to get annular eclipses. So you gotta take advantage of it while you can.
And we learned some things about the moon and the topography of the moon. So this really offered us a lot. Sometimes I feel like the annular eclipses are kind of like the Skipper to the Barbie of the total eclipse, Jim. But like, honestly, like Skipper was kind of great.
Skipper was cool. In that telescope feed, we could see the mountains of the moon.
Yeah.
And those are really cool because now we've mapped the moon so well with the Lunar Reconnaissance Orbiter that our eclipse calculations and the maps are so much more accurate, because the thing that we didn't take into account in the past were the mountains on the moon and also the terrain of the Earth itself. So now we have so much more accurate maps than we've ever had before.
I love it. You guys, thank you so much. I've learned so much from you. I want to send it back over to Jim. Jim, you enjoyed it as well. But again, like, the total gets all the attention, but like, this was awesome.
This is incredible. I mean, it was so awesome to be a part of such a big crowd too, Alex, which I was blessed with on this particular trip. And the fact that you could hear, when we went into Angularity, they were just totally roaring out there. And to hear about 80 to 100,000 people, it was like somebody scored a touchdown. I mean, that's exactly what it was like. Some of the balloonists with the burners, which is how they get the hot air balloon up, they all fired up their burners. Brad Reynolds got that on camera. It was just absolutely awesome to be a part of that. So I'm still kind of reeling in this. It was a magical moment, and you just kind of step back for a second and you process it all. There is a lot of science involved. You just heard the gentleman that Alex was talking to mention some of the things that are obviously very interesting. We got to just talk to Dr. Nikki Vile, and she is a astrophysicist, with NASA Goddard. And this is what she had to say about one of the experiments that they did while we were in the eclipse.
So right now, NASA has some rocket launches that are happening to study not the sun, but actually how the atmosphere of the Earth and the ionosphere of the Earth respond to this reduction of sunlight. The ionosphere, it's called that because the atmosphere turns into an ionized state, and so that affects how the radio waves propagate. And so it'll be like nighttime, just in that path of annularity.
Jim looks stunned.
So think about that. When we get,
I love Jim Cantori.
All right, a coronal mass ejection off the sun, you interrupt that ionosphere. That's where we see the aurora borealis as we know it. But what does it do to GPS? What does it do to our communications and things here on Earth? It does a lot, especially the stronger ones. And we haven't had one in a while, but that was like an interruption. So they could use that as a basis, if you will, for that experiment. So neat stuff, guys, both in terms of anyone who's on the ground, allowing to view it in awe, or a scientist that's trying to find essential information in our Earth's magnetic ionosphere.